The initial vision I started with was, can you build like a AI assistant very inspired by like say JARVIS from Iron Man, where it's like very autonomous, it's connected to all your data, all your services, almost as capable as having like a actual human doing things. As humans, we are very sequential. Like we can only do one thing at a time. Like I can't be like using like 10 keyboards at a time. But if I have an AI that I can just tell 10 things to at once, then the AI in a sense can go and use 10 keyboards.
Hello and welcome to Polyweb. I'm your host, Sara Landi Tortoli, and my guest today is Div Garg, computer scientist, AI researcher, and entrepreneur. His company, MultiOn, is developing an AI autonomous agent able to handle a wide range of tasks, from ordering food to booking your flights. Div has lectured and given talks at Stanford, OpenAI, DeepMind, and Apple over his research on transformers and reinforcement learning. In this conversation, we covered a wide range of topics, from building AI autonomous agents to what they will be able to do for us in the very near future, training your own data models, and what are the consequences of AGI and the risks and the opportunities. So I hope that you will enjoy this conversation as much as I did. Div, welcome to Polyweb.
Hi, excited to be here.
First of all, Div, how is it that you received an unofficial physics degree from Cornell? Do you want to give me some background story for that?
So at Cornell, I was actually in the College of Engineering, and it's like if you want to actually work in physics, they require you to be in the College of Sciences, and so it's like just like different colleges. And like I was actually very passionate about physics, so I did a lot of physics in like high school kind of stuff. Did some like physics Olympiads, and so at Cornell, I was actually taking a lot of physics courses. I actually took a lot of physics courses just to boost my grades because it was just easy to get really good grades in physics. and then like and at some point like I took a lot of advanced courses in general relativity and quantum mechanics and stuff like that. So I pretty much like fulfilled all the requirements for the physics like major. And then I talked to the dean and like it's like, yeah, like I have all these requirements and everything, and they were like, oh, sorry, like you're in like the wrong college. You need to be in the college. You need to be affiliated with this College of Sciences, not College of Engineering, to actually earn a physics degree. So I think like, they unofficially allowed me to use the title because I had satisfied all the course requirements.
Before we jump into the topic of AI agents, I was browsing for your page. You have a website where you published what you've been up to, the research that you published. And for such a young age, you published quite a bit of research and you've been invited to give talks to Stanford, OpenAI, Apple. Just very briefly, could you tell us a little bit about the impact of the research that you've done in the development of artificial intelligence, and especially the relationship with AI as we know it today and transformers?
I'm sure, definitely. So I'll say one of the first research projects I was involved with was related to autonomous driving. So like how can you make autonomous cars better, have them like work better in like actual roads. And a research I was doing there was like how can we replace lidar sensors, which are actually very expensive. Now I think the cost has come down, but they used to be like $60,000 like dollars something, which is more expensive than the cost of the car itself. And then you need this really expensive sensors to map the environment and then like detect like other vehicles and like bikes and pedestrians and like actually make sure like the car can drive safely. And that just cost is prohibitive. It's like makes it very hard to like do anything. So we came with this research idea where can we just use like a couple of cameras instead of like getting this like really expensive sensor. So we had cameras that were like that cost like $100, and then we like tried some things where we actually didn't think it'll work, but we tried like, okay, like can we take some cameras, and we were inspired by human vision, like how humans can reconstruct the surroundings by using like say like in a sense our eyes are two cameras. So we're like, okay, like if we have two cameras, can we actually go and like reconstruct the surroundings in a 3D presentation and use that for autonomous driving cars? And that actually worked out really well. So this was actually one of my first research projects I was involved in undergrad. This was my sophomore year, and I think I was trying like an experiment on the weekend. This was one of the first experiments we ran, And then I ran the whole thing, and we got like some accuracy around like 70% on like the metrics we were like tracking. And I was like, I don't know if it's that's good or bad. And then told it to my like other like PhD students I was collaborating with at Cornell. And then we did a literature survey, and we found like the previous state of art for just this like camera based solution was like 20%. And then there was like just really surprised, like we're like, okay, like, oh, we somehow like improved the state of art 3x. And then we spent a lot of, like almost a month just making sure like we were not accidentally leaking any data. All the experiments were actually correct. And so that was a lot of fun. And that eventually I think we got like a lot of coverage over that. So we had like a lot of like Forbes coverage, a lot of media articles about their research. So that was a lot of fun. And that's also one of my first exposures to like AI, and sort of like what, like there's like so much to be done in a sense. So like, okay, like, yeah, you can just go and like run some experiments on a weekend, and then like that can actually make a big impact. So that was just like fascinating to see. And I think like that's how I got more fascinated by more like autonomous systems and robotics, and like how can you keep like making sure like everything, can you make things more smarter over time. And I would say like after that, so I worked in like autonomous driving for 2 years in like different like startups and like industry labs. So I was working in like Google research and like Nvidia. Uber used to have like autonomous driving divisions. I was working there too. And then I just saw like the space was too early, like no one was able to figure out how to make these things work at that point. And then I decided to move, like sort of focus more on algorithms. Like how can you create more intelligent algorithms, because that seemed to be the lacking thing, because a lot of people had built this like really complicated like hardware systems and like figure out everything, but like there was no AI that actually worked. So like unless you figure out the AI, you can build anything you want, but it's not going to drive it. And then like, so a lot of my focus in Stanford was like, can you create like more intelligent like AI algorithms. I was focused a lot on like reinforcement learning, and I worked on a lot of methods for, can you do better imitation learning from like watching like human videos or mimicking humans and scale that out. Can you like scale out a lot of like this like reinforcement learning algorithms to work in the real world? And so I led like a couple of projects. One of the projects I led was how can you teach AI bot to play Minecraft? And so this was part of like a NeurIPS competition in 2021, and we were given like a lot of like videos from human players who were going around like say building houses in Minecraft and exploring caves, building animal like pants and stuff like that. And I had a very recent work at that point called inverse q learning, IQ learn for short. And we had just published that to the same conference actually, just like 2-3 months before. And then that actually we got like state of art in like everything. It was very novel because like there used to be a similar algorithm that actually came from my lab at Stanford 5 years ago, and like this was like the sort of the first big improvement on top of that. So that was a lot of fun. And so we were like, okay, let's see what can we do with this algorithm. So we tried this on the Minecraft environment, which was like really challenging, and it was surprising, like it actually worked really really well. And so like there were a lot of other methods. We were just trying heuristics and like a bunch of like a lot of like very very like manual stuff. But for us, we basically just threw in everything in our algorithm, and the algorithm was able to actually work really well, and we got the number one prize in the competition. So that was like very fascinating to work on. And and then sort of like continuing my journey, I was also working on a lot on language later at Stanford, where I was interested in like, can you get a language condition actions, where can I have a robotic system which I can talk to or ask it to do things. And this was actually also, I will say, like one of the first applications of language and actions together with like deep neural networks, because like people had not done that before. And so we were working on the system where can you control a robotic arm using language. Can you ask it to go open a drawer or like pick up a mug? And then we figured out like a bunch of things to make it work really well. This was still early. I think this was 2022. So this was before like like language models and everything become like a large phenomena. We were not training that big language models at the point because Stanford has very limited compute. I actually got banned from the cluster because I was, so you're only allowed to use like 20 GPUs at a time. There's like a lot of restrictions because everyone's fighting over GPUs. And I found a way to like hack the system, and I was using 100 GPUs at a time, and then just pissed off a lot of people because like I was like, oh, like they were like going to the clusters like, who's using all the GPUs? And I was like, oh, they were too good just using every single GPU on the cluster. And this was like I was just using the whole cluster for the CS department at Stanford, so like a lot of people were actually pissed. So that was fun. And then like, so yeah, and then after that I was working on some more like robotic stuff. So I was at a robotic startup for a bit, for a couple of months, working on like more like human inspired robots, and like how can you have like robots that actually are fully functional, can like move around, do things. and then how can you put them in different environments, like say like hotels or hospitals and stuff like that. So that was like really fascinating. And at some point I realized like that I think like the thing that you need to solve is software right now, where like if you can go and like automate software, like give a brain to software itself, then they're just gonna change a lot of things. And I think that was sort of my motivation to like start this company. And I like to say to a lot of people that if you want to solve AI, you first need to build Jarvis before you go and build something like Ultron.
That's true. I think that's true. So, you are the founder of MultiOn, and MultiOn is an AI autonomous agent. So,
Mhm.
just so that we are all on the same page, could you give us a definition of what is an AI autonomous agent and what does a successful AI autonomous agent do?
So an autonomous agent, I will say, is something that can act in an environment that it's given. So given some sort of task specification, which could be through a language or some sort of goal, it's able to like intelligently act in the surroundings to reach that task or like, fulfill the task or reach the goal in some sort of like given environment. And the environment could be anything, like it could be like something like they say the digital world, like the internet. It could be the physical world in case of robots. It could be a video game, something like Minecraft, for example. And then the autonomous agent is like acting on its own, so in a sense it has its own intelligence, and it's able to like use that to fulfill like a given like objective by taking acting in that environment. So I would say that's like sort of the high level definition. Right now I think there's a lot of like hype around like just agents in general. So I think a lot of people have rediscovered it, but if you look at like a lot of literature in especially in reinforcement learning, like agents is actually like a term that's been used for like 50 plus years actually. So it's just like a lot of people now now just become mainstream, and so people are like agents, but like agents actually like a very like a very like known thing in a sense, at least in academia.
Yeah. But it's for sure like a developing field. And so maybe you could talk a bit about Multion. What does it do as an autonomous agent? Because I saw a few spinning out, but they are delivered in different ways. So you chose a very specific way, which is that of a browser extension. Maybe you can explain why you chose, for example, the browser extension form, and what are the specific use cases that you envision people will use your AI autonomous agent.
So one of the reasons we decided to go the browser route, let me start with that, was because browsers are so general purpose. This is like literally what every single human interacts with for every digital interaction. And it's just like so commonplace. Almost everything has a web app or a website. And so if you can like go and like have an intelligent browser, then like that is good enough to solve like 95% of the problems where you want to like interact with websites or do things for a user. So that was one of the reasons to like build like a browser based AI, because like that's the easiest way to like act on the internet. If you think about the internet as environment, then I feel like the browser is like the most unrestricted way to like go and like do anything on the internet. And then I started like working on the browser extension. I will say the reason I will actually say was more on like development ease, because like there's actually a lot of form factors you can build, and we experiment with a lot of different things now. But like I think when you have to start, you want to make sure like you can actually go iterate on it really, really fast, and also that it's as tangible as possible. And so like a browser extension, the nice thing is it just like directly lives in my browser. So whenever like I'm opening my browser, and like I'll say like whenever I open a laptop, 90% of my time is spent on the browser. So it's always there, so like I can just go and interact with it. So just because it's always there just makes it so easy to like just interact with it, keep developing it, do things, like make it a part of your everyday life. And uh, and and second I will say is also it has like access to my a lot of like logins and passwords and stuff like that. So it's very easy to give it authorization, and very easy to like sort of like also like test it out. Well, like if I want to test it out, I just give it something, and then it's actually just going doing that while I'm like watching it like as part of my everyday. I don't have to even like do anything spatial, right? Because I'm just already have the browser open. I already have everything. I just ask it like, oh, can you try and do this? And then that basically just becomes your testing, where you're just having fun, just playing around with this AI that's already there, and then you're just like trying out different things and seeing like, okay, like what works, what doesn't work. And then it just makes it like very easy to iterate, because you just like, yeah, so it's like, because it's like a very tangible.
Absolutely. I mean, I spend also, I think, 90% of my time when my computer is on a browser, actually several browsers, if I have to be honest, more than one. But like, give me some examples of use cases in which people can interact with an AI autonomous agent.
So I'll say overall, like the browser extension is very general purpose. So it's like you can use it on any websites. And I will say we are actively improving it over time. So I will call it like almost like a prototype where like it's not like fully working on every website. We support, I will say, like on the major websites, it actually works really well. So we have 95% compatibility with all most of the major websites. But if it's like a random website on the internet, it's very hard to say because we don't know if you have trained on the website or not, or we've seen the website or not. And so we are like actively refining it and like improving it. And I think like a lot of use cases we are seeing right now has been around like people using it for a lot of executive assistant or manual tasks which are repetitive. So an example is like I'm actually using it a lot for like sending like documents to people. It's like if I have to send an NDA or something to see someone, I'm like, oh, can you send an NDA to this email for me? And it's like so much easier because like I can just like I don't have to go and do that, right? And like similarly, like you can use it for a lot of like admin tasks. It's like, oh, can you like add someone to this like AWS account, or can you add someone to this Slack account? Can you add someone to GitHub? Can you send someone a LinkedIn message? Or like so sort of like it becomes like a very easy way where like normally how things work is like you first think of something, then you have to like actually act on that, and then you have to like go to your keyboard and mouse, type it out, do the thing, and then you like do that again and again. But in this case it becomes nice because it's sort of becomes delegation where like I think of something, I just tell it to the AI knows it, and I'm like, okay, like cool, like, let's go to the next thing. So just like saves you a lot of time because as humans we are very sequential, like we can only do one thing at a time. Like I can't be like using like 10 keyboards at a time. But if I have an AI that I can just tell 10 things to at once, then the AI in a sense can go and use 10 keyboards.
Yeah, that's the beauty of it, right? But I'm curious to know, how does it work under the hood? Some tasks are very straightforward, like the
Yep.
example that you gave, give access to someone into GitHub, etc. But I think that there is a lot of variability and unpredictability as well that is inherent in some tasks and that needs to take into account human preferences. So how do you handle also this type of variability, if that makes sense?
No, definitely. I think it's very important because if you have an autonomous agent and if it's fully autonomous, then it can just make its own decisions, which might not be what you want. And I think we've actually spent a lot of time thinking about it. Like for me, like a good example could be like say say something like order like something on DoorDash for me, like could be like a burger or something, and then can go and like choose something potentially on its own and like order it to me and comes to my doorstep. I'm like, no, I wanted a different burger. Like this is the wrong burger. So it's like so that's like sort of feels bad. And you can imagine the same thing for like flights or you're ordering like clothes. People are very selective for a lot of these things. And so what we've done right now is experiment a lot with like how can you make the AI more like ask user more questions or like ask for more user options in a sense, where if the AI it doesn't know maybe like what the user wants, it can like stop and say like, oh, I have found this like three particular items for you which you might like, and then can like list them out. And then like the user can choose like, oh, like this one looks interesting, and you can ask it more questions like, okay, what's the price, what is it like, maybe like show me the link to that or something. But once you decide, then the AI can like then go and like buy it for you. But I think like in a sense we still want the humans or like the user to be the person who's like making all the decisions on what to get. But the nice thing here is like once we start learning a lot of the preferences over time, then we can make sure like it's more aligned, so the recommendation gets better. It's able to like sort of like become more personalized. And I think this is very similar to anyone who has worked with a personal assistant or an executive assistant. I think initially what happens is you give them like a big onboarding survey of like how you do things, what you like, stuff like that. And then as you work with them, the executive assistant becomes more trained, and then sort of realize, okay, like this is like become more aligned with you. They know, okay, like this is what I like. This is what my everyday routine looks like. And then you don't have to tell them; they can automatically like do these things without you telling them because they just like know you so well at that point over a couple of months. And I think the same thing will happen with AI, where like it just knows you to such a good extent. You will just trust it enough. You will like, okay, like yeah, now you can like go and like just automatically do this for me without necessarily needing me in the loop, just because I've seen like, okay, like you can do this really well.
Okay, interesting. So this begs another question, which is in developing such an AI that is able to fulfill a wide ranges of tasks, what are or were the most difficult technical challenges that you face and that you need to overcome?
So I said, yeah, generalization is can be very hard because if you want to build something that can work on like there's like probably like a million plus websites on the internet, so you want to build something that can work on the whole internet. That's very challenging because you have to make sure like it works everywhere, and that requires like a lot of different things you have to do. Second challenge I will just say is variability because like suppose we change something and then we never know like okay like did it improve? Maybe it improved on some websites, but it might have degraded the performance on some other websites. So it sort of becomes very hard to test it out. So I think like that's what we have been like trying to do right now is just like how do you do like very robust benchmarking evaluation whenever we make a change we can like actually know like okay like this doesn't impair some of the functionality. And I will definitely say that's one of the biggest challenges right now. It's just like keep improving the product and making sure like okay like we can actually like make it work better and better on everything. And then I think that becomes like very challenging, and that's sort of like the biggest thing we're trying to conquer right now. And we're also like starting with more specialized use cases where like okay like even if we can get like say like 99.9% accuracy in a couple of use cases, which is like really good, and then we can like keep improving that over time, but we don't have to like really try to aim for like 99.9 like everywhere.
If you imagine, the ideal end state of MultiOn, what will that be? Like, what will they be able to do? And what do you think should be the limitations in place?
So I will start with what it should be able to do. So I would say the initial vision I started with was like, can you build like a AI assistant, sort of like maybe like very inspired by like say JARVIS from Iron Man, where it's like very autonomous, it's connected to all your data, all your services, and it's able to like act on that. So in a sense, we do see that world where like it can become like very capable, like almost as capable as having like a actual human doing things. And I think that's where we want to go. A lot of things can go wrong there, and I think that's where we are very careful about like the safety risk, privacy risk, security risk, where like a lot of people could potentially try to hack into the system or like make it like try to do like bad things, do prompt injection. So how do you like secure yourselves from that? How do you also make sure like everything remains private, especially because it's a personal, like it's a personalized system, so it has to know things about you. But how can we do that in a way where we are not actually like leaking the data or storing the data directly on our servers in like a human readable format, or like leaking that out? And the third thing becomes also I would say control, where like okay now you have this thing which is like almost like a human, and then you're like working with them, so it could be like maybe think of it as like maybe you're like a best AI buddy or like sort of like a best friend in a sense. And most of the time it might do things you want, but what happens if it does something that you didn't want, or it started like doing more decision making than you might want? And I think like you need to have a control level where like you can switch it like okay like it works on these things, but I don't want it to work on this parts of my life in a sense. And I think like that's I think what we are like working a lot on, like figuring that out, like okay like what's the right balance where this doesn't become too intrusive or too like taking over my life kind of thing, but still like it's really helpful.
Yeah, I mean, I can imagine that if I make a transaction, no, no, not I, sorry, the AI agent makes a transaction, I don't see the customer service of PayPal or like Venmo be equipped to the query. Oh, my AI autonomous agents did this by mistake. So that's also another
And yeah, and
challenge.
I think it's going to happen, and I think that'll be very interesting to see like how will that play out in long term, because like a lot of payments might go through autonomous systems, and then like it becomes a lot of things around like reliability, and like also who owns the mistake if something goes wrong. Say, is it on the company, is it on the user, is there a way to like reverse that mistake, get refunds? And so we'll have to build like new financial mechanisms that are made for more like AI systems and not humans.
Yeah, not just for payments, but for all sorts of stuff. So multi-on feels to me like it's more like consumer to consumer. But if I think about, okay, what could be the use case application in B2B? So all of a sudden, this becomes very interesting because it's not just ordering my food or book my flight, but it could be all sorts of tasks that previously were done by normal employee. And so I'm curious, like, how do you think about businesses applications and the risks that you see there?
So, yeah, there's a lot of B2B applications, and there's definitely a lot of things where this could be our like virtual employee kind of thing. And we have actually seen a lot of interest where we started as pure consumer and we give access to a lot of people, and a lot of people came with us and like, oh, like this is really cool, we like to use it in our businesses, how can we use it in our businesses? And we actually get the question a lot. Like I get the question like, I have maybe like 5 people pinging me every day, like, "Oh, I would like to use MultiOn in this like use case in my business. Can you go and support this?" And so I would say that that's definitely one big problem. One thing we've seen is like when it comes to like a very like a general purpose tool like this, like everyone has different needs and like want to like do different things. And so we've been thinking about like how can we like set it up in a way where like we don't have to go and support a lot of use cases directly, but can we like set it up in a developer tool kind of like basis where we give them like some access to our agent over APIs, so they can like, go and like embed it into their functionality, start using it. And we have seen like some interesting experiments we're doing there with a couple of customers, and so we are looking into that currently. I do think that the market might be fragmented though, because I think what happens is like if it's a really really big market, then everyone wants to try and do the same thing. So maybe I would say like 2 or 3 years from now, there'll be a lot of people building virtual employees and stuff like that. So we want to make sure like we are disciplined and like we focus on the right side of problems, because I think this is actually from Peter Thiel, I think. Because if it's a really really big market, then that's actually really bad, because then everyone will just go and build the same thing. So so you don't want to be in that boat.
Right now, MultiOn is in closed. You need to
Yep.
be in the Discord to be able to download the extension, and I feel that this is very much intended to sort of mitigate the risks that we were talking about before, right? You don't want to unleash it and then people start giving credit cards left and right. But how do you think about the actual launch, a public launch? I mean, of MultiOn. How do you plan to see it through? Who do you plan to target? Because you could go so many ways, right? You have already businesses kind of messaging you all the time. There is the larger consumer markets. So, how do you think about that?
I would say we have a really big wait list. So we have 50,000 people on a wait list. We have done a lot of surveys around use cases. And so I think we're prioritizing access based on like what we think are like the right use cases people can start using it for right now. And then like sort of like improve that over time. So right now I think we want people to treat it more as like a like sort of play with it, experiment with it, find out like okay, like where it fits in their everyday life. And so I think like we are moving to more alpha in this month, and like sort of like doing some more soft launches kind of stuff like that. So I think we might be in more like currently we're in a very close beta. I think we might open that beta to more people, get a lot of people out the beta list. In general public, I think there's just like a lot of moderation issues and stuff like that where we don't want to just like give it out to like millions of people right now. So we do want to play that a bit safe and like also just like test out a bit. How do you put a lot of guardrails and like how do you make sure like everything is secure? But we do see a pathway there where we are, I think like by I would say maybe like mid January to like late January, I think we'll be very open in the sense like a lot of people might be able to go and access our agent, at least in a like a exploratory sense of way where they can go and play with it and like figure out where to use it. And then we are building like more specialized sort of like use cases or product like applications in different form factors. So we're thinking of potentially launching a mobile app so you can just use it from a phone, stuff like that. And I feel like that might be a better way to make sure like nothing goes wrong, because then you can put more safety guardrails. Because right now what you're seeing is the agent directly in its raw form. So it's basically like okay, like if the agent does something, it does something. Like it's like we have zero control because it's just running on your laptop.
Sure.
And but like if we are running it on like if we are using it through a phone or something, what we can do is we can run it on our own backends or on the cloud, and then we can actually like put some like control levers and like make sure like it doesn't go doing something wrong. And so I think like that will be like interesting over the long term as a way to like safely distribute it.
That's interesting. Is this open source or not? The entire
No, I
project?
think we decided not to open source it just because we didn't want to like sort of like have people misuse it or create like sort of like use it for malicious purposes. So in a sense, we that was one of the reasons we haven't open sourced the technology itself, because I think the having the technology as right like the spatially fit like can work on the whole internet, do a lot of things. I think that becomes very risky. So it's possible we might like open up some parts of the technology, but I don't think we want to risk opening everything right now.
How do you feel about this dichotomy between open source AI versus closed source in general, not just related to Multion? Because this is like a big, big debate.
Yeah, I think it's definitely a big debate. I would say there's like pros and cons. There's definitely like a lot of like open source movement, and it's very easy to develop and like for people to see what's happening, stuff like that. The risk is just like if something is open source, it's like literally out there, so like anyone can use it. This could be like a bad person. This could be like anyone in like say like Russia or China or some like place where like okay like yeah let's just create some sort of AI virus or something that can go on the internet and like spam people. And so there's actually a lot of bad actors, and I think that's one of the biggest worries for us right now. It's like how do we prevent that? Because once you give this house, okay, like I think one reason we also try to be careful is what happens is when there's like a very big change in technology, like what's happening right now, you can enable a lot of things. So if you look at like a lot of like things like say the nuclear technology, for example, so that suddenly became possible, but like that was like very like the reason like it's so secretive is just because like it has so much huge implications if someone knew how to build that. Similarly with like a lot of things around like even like say like chemical weapons and stuff like that. So I think it's some technologies are easy to weaponize, and I think that that's why you try to keep them closed source so people don't go and weaponize them. And I do see like a similar thing here where it might be like people could go and try to weaponize this and like formats of viruses and stuff like that. And that's one of the reasons we don't want to take the risk right now. The good thing is like you can always go and open source it. Like once you open source, it's hard to reverse the decision. But if it's closed source, like we can always decide to like okay, like now maybe this is a good time to just like put it out there. I will also say a good analogy here might be operating systems. So if you look at like there's a lot of operating systems which are some of them are open source, like Linux, for example. And Linux actually has a very good adoption. But if you look at like what mostly runs on most people's laptops is like Mac OS or like Windows, which are actually closed source. And closed source has this advantage where like um it's just like people really want to work on it and like sort of like keep improving it, maintaining it. Whereas open source, what happens is like you lose the momentum and steam after a while. So just like
Mhm.
people get disinterested. And I think like that's sort of also like I do feel there'll be a lot of open source agents, but the best agent might just be closed source because we might just have a really good dedicated group of people who just want to go and like build it all the time. And I think the best way to do that is through like a project where like like you do it as a company and like everyone can go and like work on that together. Whereas like open
Yeah.
source, it just becomes harder to do that because you just have so many maintainers and people just like leave all the time, and there's just like a lot of hassle maintaining projects. So I think there's like pros and cons, but I feel like operating systems are a good analogy of what might happen to agents over time.
That's true. I also have kind of mixed feelings, and I'm like, oh, I'm not sure. Like it's, as you said, pros and cons, right? Going back to the topic of autonomous agents, how do you think it will change our daily life and daily routine? Not right now, but perhaps like let's look 2 years from now.
Yeah, so I'll say even 2 years right now feels like a very far in the future just because of how things are moving.
True.
So I'll definitely say a lot of things will change. I think we are still missing the like the sort of the iPhone moment where it just like changes everyday life completely. And I think that's going to happen. I think in the next 2 years, where a lot of currently like I would say like when we do something, it's very solo, right? So you just go and do that, and like it's a very single player. But what will happen is like whatever you do, there'll be an agent involved. So everything will become a collaborative experience, or like or something where you can delegate things. I think it's starting to happen in some places where like for coding, for example, now you can like collaborate with the AI agent and like delegate things, but that's very very specific right now. But I think the same thing is going to happen in everyday digital interactions where everything will become a collaborative experience. And I think that will be the new sort of like iPhone moment where you're just not alone anymore.
And this passed through a lot of things because right now, the way all technologies are designed for you to be alone in that technology. Every single one, from the phone that we're using to all the apps that we're using, they're all walled gardens that they guard, their data like this. They seldom communicate. And this will require a change, both in terms of interaction design, so how humans interact with technologies. I had a conversation with an interaction designer at Humane, the AI pin company. And so it was explaining how they are trying to solve this problem of interacting with multiple people and technologies at the same time. So you need to design a new experience, but you need to design also new business models. I feel that right now don't support this type of collaborative and cooperative interaction.
I totally agree. I think yeah, a lot of these experiences will change. Even if you look at like the concept of apps, you might just not even need an app because I can just like ask an AI to like go and like do all the things. So I think lot of the things might disappear, especially if you can remove them and reduce friction. And so I think a lot of the things like might just become like very simple, or you might not need an explicit app for that anymore. And I think that's going to happen because it will just open so many doors. I do feel like the right form of interaction is just like if I could just like talk to like something that's like human like and just knows how to operate the whole system or the apps and like everything for me, and then I can just tell it like, oh, like this is what I want to do. So it's like talking to your computer, and if the computer was intelligent enough that it can like figure out what operations to run based on what I told it, and then it ran all the operations and then gave me the final result, like I'll be really happy. And I think that's what most people want actually.
Yeah. Yeah, probably, right? So, speaking of the way technology is designed, a lot of the listeners of this podcast are aspiring entrepreneurs or are just getting started. So, I'm curious to know, how would you suggest that they try to implement and leverage AI in the context of a startup, especially because when you're starting out, you don't have the capacity or resources to train your own large language model. So, how can you how do you start training your own data set if you don't have that type of resources, which I imagine is also the problem that you faced at the beginning, right? Unless you still were stealing GPU from Stanford. But otherwise, right?
I wish.
You will,
Well,
so kind of you face also the same problem, I guess, at the beginning. So how do you solve for this
definitely.
problem? I know that there are some papers right now flying around related to training with synthetic data, but even that, like, how do you get access to those?
So I'll say the good news is you don't have to train a model from scratch anymore because there's like so many good open source models out there. And I think what now I think people will start to realize is it's like I think it's just like how clever you are in training a model, and that's what matters. Like if I can go and collect a lot of like really good data which no one has, or I can just like make sure like everything is like really really good. Like I think the quality of the data is something that matters a lot. And so if I have really good formats, really good data, then I think right now, maybe even if you have like a couple of GPUs, could be like even like one single GPU, which you can rent out from on the cloud. So there's a lot of services like RunPod and like even like AWS or anything. You can get a cloud GPU and you can train a model like maybe like for 5 hours or 8 hours, and that's actually pretty good. Now, like these days, you can train like a 30 billion parameter model for like a one day, and then it can actually be really good itself as long as you're really clever about like what sort of data you train it on, how you train it, what sort of your formats look like. And so I think like yeah, so I think that's really good because like now if I want to build an AI application, I don't really have to go start from scratch unless like I'm trying to solve like I'm trying to do like DNA modeling or something. Then in that case maybe you should better start from scratch. But if I'm doing something just like language based, there's already so much language based models out there that you can just go and like fine tune them on things you care about, and it's all about like being really clever on what how you do it.
Yeah, that's not easy, right? Though, like, even starting, yeah, no, I know, because like I'm also trying right now. So I'm also speaking like from a personal pain point. Because at the beginning is the key is it's true you can get a lot of open source data and models right now, but the key to make something truly stand out is to find those unique data, this unique perspective, right? That will allow to differentiate yourself, because right now what we are seeing is a lot of copycat that really add nothing compared to what ChatGPT can do, right? You just go to ChatGPT and you ask, and it does exactly the same thing. You don't need to pay for other subscriptions, let's say. So, how would you suggest listeners approaching this type of problem?
Yeah, I'll say a lot of it just like your unique viewpoint, or in a sense like your taste in a sense. Well, like okay, like I think even if you look at traditional engineering, like if you forget about AI, like it's like if you look at traditional engineering where people build apps and like everything, and like there's like definitely apps that are still like number one or like people use a lot, and like, a lot of it just like building things that people want, and like what's like yours like unique viewpoint or like a unique experience, and how can you bring that out into the product and give a life to it. And I think that's what will start to become important, because I think AI will just be like an ingredient in a sense. Like you want to go and build the best possible thing, and AI is probably one of the ingredients. But I think like what will help the most is just like how the person like sort of like puts their past experiences, what they like, or what they want to build, and then build that in a really like a good way, so that people love that application. So I will definitely say like focusing on the application, and I think this is similar to maybe like the traditional product building, like try to build something but like not focus on the AI, because AI will maybe like just become like one of the parts, and AI as a problem will become solved. But like you can definitely like you go and like use it, but your product doesn't like you don't have to start from AI as the first thing that you have to solve to build that product.
Yeah, that's absolutely true and an interesting perspective. How is it for you to transition from the world of research at Stanford, because you were doing a PhD, if I'm not mistaken,
Right.
to become a founder? And what are your biggest learnings so far?
I will say starting is the hardest thing. So I think the it's all like I will say like 50% of the work is just like taking the leap. I do feel like things get much easier once you get used to it. So like right now I feel like okay, like yeah, like it seemed like a lot of hard work at that point, but right now I just feel like okay, like yeah, like it doesn't seem like that hard just because I got used to it. So it's a lot of the things is just like learning this like new skills where you have to like go talk to VCs, or just like prepare a lot of presentations, or like know how to like market things, and like sort of going out of the comfort zone. So I think that's a hard zone. It's like sort of like moving outside your comfort zone, doing new things, and once you get used to like once that becomes a new comfort zone, then I think like you don't even like think that's hard anymore. So I think so that's one thing. And I would say like for startups, the one very important thing is just to be able to move really fast. So can you like keep quickly adapt to new things, and like always be flexible, trying out new things without being overly rigid. And I think like that becomes really, really important, and also being just open to new ideas. So for me, like research lifestyle, I was pretty much having zero meetings. Like I was trying to minimize my meetings. I had 1 or 2 meetings a week, which was mostly with my research advisor or some collaborators, and like most of the time was just spent on like ideas and just thinking about things, and like trying out different experiments. So it's like, and when you move to like a startup lifestyle, it's like almost the complete opposite, where you're just like talking to so many people all the time, and like working very like as like a sort of like with a lot of people, managing a team and stuff like that. And I think it's definitely very interesting just to like experience so many things. So I would definitely say like I feel like a startup for me has been a crash course into maybe like learning or working with humans. So like now I would say like 1 year from now I had maybe a very less clue on like how humans like how humans work in a sense, or like how to work together with people really well, how to manage people. But now I'm like have become really good at that. Like it's like okay, like, now I know how to do this really well.
It's like a bit of a roller coaster, right? And the great thing, as you said, is every day you learn new things. One thing that I was thinking about while you were talking about this, especially in the AI space, we're seeing things moving very, very quickly. What I feel like is that it won't take much time for other companies to start popping up and kind of trying to replicate what you're doing. I mean, there are already attempts. They maybe focus and do this in a different way, like using different means. So, for example, no browser extension. But I think that the browser extension is very clever. So I wouldn't be surprised if there are other companies right now that are trying to replicate what you're doing. How do you differentiate your virtual assistant, your AI agent from the competition?
Yeah, not totally agreed. Like I also like there's always going to be copycats for whatever you do. What I think becomes really important is one is like you want to build something like that you want to use first of all, because like you have to think of like okay, like if you were the user, what's the perfect thing you build. And I think that influences a lot of like say like the decision making, where like okay, like this is like how do you build this into something that people really want. And so I think that becomes really important. And second I will say is also just like a lot of dedication, because like what happens is when you want to build something really, really good, you just have to like spend a lot of time doing micro optimizations, or just like solving a lot of things around like okay, like how do I make this like maybe like even like 10% faster, where like you might just go spend like I don't know, like a week or two, and just like maybe you can make it 10% faster, where you just like did like so many like random things that no one even realized was possible. And And so you have to just go and like sort of like in a sense like think of it as like you have to basically become an artist in a sense where like okay like you are trying to create this like sort of masterpiece and you just go refine, and that's the only way to get there. And I think that is sort of dedication. I think is something that a lot of people lack. And if you look at like good consumer products versus bad consumer products, I think that's what is the differentiator. So if you look at something like even like Apple builds, they've spent like I don't know like so many amount of months like slaving over every single thing or making sure everything fits in the right place, and that's why people love their technology and their products. And I think like a similar thing will happen with agents where like okay like can you make sure that every single thing fits really well? Can you build something that like is like a super well like a just like works out of the box experience and people feel like it's magic? And I don't think most people can go and build that, just because you just need crazy amount of dedication and you really need to love building what you're doing. Like, and I think like that's something, unless if you're just like there for money, I think it's very hard to do that.
Yeah. I feel that when it comes to AI, autonomous agents in particular, one element that is crucial is building trust with your user base. That you start to trust the AI autonomous agent, because when the trust element is installed, then it would be very difficult. Like, why will people switch? Right.
Basically.
So I feel that trust is an important element in every human relationship. And contrary to the relationship that I have with the normal apps that I have on my phone, I'm using Facebook even if I don't trust it with my data,
Right.
but still I use it.
Yeah.
Uh,
Yes.
but I wouldn't do the same with an AI autonomous agent, because I'm entrusting it with executing task for me on my behalf. So I feel like that would be the turning point for everyone building this type of technologies. If you are one of the first or the first mover to market and you're able to build trust very very quickly, then you're basically becoming the market leader, and you have a nice user experience as well, because that's always
Yeah,
counting,
definitely. Yeah,
right?
and I totally agree on a lot of it's about trust. If I trust this thing, then I don't want to go and like move away. Also like personalization, because suppose it knows a lot of things about you. Yes, you spend a lot of time just like training it to or making it know you better, and then I don't want to go and like go get another thing because I'm already like spend like invested my time and energy into the one thing. And I think a lot of that starts with building trust, where you want to make sure like we don't accidentally do something unsafe. So can we earn the user trust? I think that's going to be the very interesting set of challenges. And I think yeah, I totally agree. And it's also like it's interesting that this is like one of the hardest challenges for autonomous agents. But if you look at like a traditional product, it's like it's kind of like the easiest thing, because like when you're building a normal product, like it's not hard to well, like earn user trust, because like usually like it's not doing decision making for you. You're doing everything, so like okay, like I trust this because I'm doing everything. Autonomous agents, the thing becomes like because like now this thing is going and doing things. Like how can I like how do you build that trust? So I think
Yeah.
it's a very interesting problem. Yeah.
Yeah, because like if I think about it, so at the beginning, if I think about starting using MultiOn, so at the beginning, I will give it a very simple task that I don't really care about. Meaning,
Basically.
if it screws up, I mean,
Yes.
we can live with that. And then over time, as I see as I see it in action, I will give it increasingly more complex stuff. And then maybe one day I will give it my credit card and stuff like that. So, but it takes time, because like if you think about how our trust is built in human relationship, it's not going to be that different, but the bond is going to be even more permanent, because there are no feelings on the AI part involved, because a lot of trust elements in human relationship are kind of biased or mitigated, because both parts have feelings that can be contrasting, right? That
Yep.
won't be the case with an AI autonomous agent. So I think it's an interesting aspect and interesting dynamics that we haven't seen so far, and that startups in this space will need to spend some time thinking about.
No, definitely. Yeah, totally agreed about this. We have some very interesting things we've thought about. Like this is actually something me and my co-founder spent a lot of time thinking. Like exactly this. Like okay, like what's some interesting things that are low risk, maybe like a good way to like get people like start using it. And so we're actually working on a lot of cool things here, which we'll be announcing soon. But I do agree. Like you have to like start with one thing and then like over time, like it's like sort of like you want to build a relationship with the agent, so you have to first enter the friendship phase before you go to like the marriage phase.
Exactly. Yeah. Because then it's like that. Once you trust it, it's like a
Right.
marriage. Like I train you and then you become my trusted right hand, my my advisor, executioner, right hand. So, okay, I want to switch gear because we are coming up toward the conclusion. And I want to talk about AGI. So, first of all, we have seen lots of definition flying around of AGI. DeepMind even published, yeah, I think it was DeepMind, it's Google, yeah. They published a paper giving a table with definition of AGI and different degrees. So, how as a not only as a founder in the space but as a researcher in the space, what is AGI and is it possible?
Yeah, I would say there's a lot of different definitions as you mentioned about AGI. Like I think one definition I like is more based on like the Turing test, where can it go and fool a human and into like thinking it's a actual human if you're like interacting over like a phone or like through like a and there's actually like a like different criteria for passing the like the full general like Turing test. And I feel like actually like GPT-4 can pass most of them right now because I think it's the sufficient prompting. It can act like very much like a human. It can take maybe like hold like a 10-minute conversation potentially with someone where like you might not be able to tell it's AI. I think one thing we are lacking is I think like the Turing test also requires that the AI is able to take action, like physical actions. So it has like dexterous control and it's able to like do stuff like fine, like sort of like fine manipulation. So it can like maybe like turn screws and like actually like control a robotic arm and do things. So I think that is one thing we are lacking right now, where we don't have the physical actuation capabilities. But I feel like in the digital sense, I think we have passed the Turing test, except the physical part. And so I do feel like we are in that sense we can say maybe like yeah AGI is like close, it's not that far away, and I will definitely say like AGI will be achieved because we have all the ingredients, and then there doesn't seem to be any sort of like actual limits on intelligence itself. So it's like there doesn't seem to be any law that says like okay like you can't have an IQ above this level. So I do think like it's possible to build systems which will have more than human IQ, and it will just become very interesting. Like once you do that, how do you regulate the systems? How do you make sure nothing goes wrong? And also like how do you put this to practice once you like start putting this out there in the wild?
Yeah, how do you do that? How do you build those sorts of guardrails if the machine is more intelligent than you? Why should a human listen to a monkey, right? Where we are the monkey in this case, and the machine has become the new human.
No, definitely. And I do feel like the question just becomes like I think one big question will be like, do should we go and build super intelligence, even if we can, right? Because like you can be like maybe like we can build something that's like close to human level or maybe like slightly below, but that would be good enough. Like if I wanted to build a personal assistant, like that's actually good enough. Like I don't need to go build something that's like much more smarter than like a average human. If it's like maybe like slightly below, like less capacity, like less intelligence than an average human, I think that's pretty good for a personal assistant. And so a lot of the questions might just become like based on what you want to build, how much capability do you want really? And I feel like what might happen is like you might just have different like zones in a sense, where like there will be a lot of regulations and the government might create something, some sort of like, I don't think we're still like a metric, but there might be some metric where you can like measure the intelligent quotient of an AI and be like, okay, like if like before you go and deploy an AI in the real world, you might have to earn a certificate, show how much capable it is. And if it passes like some sort of like a red zone barrier, like then it becomes like very like guardrail, like the development of that will be prohibited. There might be some like more like a yellow zone, this is like restricted but you can get a license or something. And there might be like sort of like a green zone, like okay, like you can do whatever you want as long as it doesn't go exceed that requirements. And so I feel like there might be a lot of safety regulations around like what is the right level of intelligent quotient a particular AI solution might have. And the interesting thing I will say is just like you just don't really need that much IQ for a lot of things, unless I want to go solve like like hard science.
True. Which is also interesting. I mean, there is a lot of hard science that would be incredible if we were able to solve this, starting from the medical field to energy. There is so many things that AI could help us if it has an IQ above human intelligence. So I can see the good and the bad at the same time. But who do you think should put those red flag? Who should decide basically where the line is drawn and what is good and what is not?
I would say like the right way will be to have like experts decide. So like have a committee of like AI experts and have them be able to decide, because I think the creators of a technology are the most familiar with the dangers of the technology, of how can you misuse it. And so I feel like they have the best uh, sort of like experience or the best way to like go and moderate it. And I do think like we will need more of that. But I will definitely say like it should be like the experts and like the maybe like the government collaborating and like setting up some sort of like potential like AI body in the future. It's still will be very interesting to see too, because like what happens is when you have like this sort of like national interest and stuff like that, it becomes a race. It's like every like nation might just try to go and like just secretly maybe just try to create super intelligence and like use it for their own benefit. So I think it will definitely create this super intelligent race which we haven't seen yet, but I think that might potentially happen.
Yeah, I think if it's not already happening, it's very difficult to draw the line and establish like a sort of, test, like if it's below this, yes, you can release it to market. If it's above this IQ, you cannot, because it feels like countries will compete for this type of technology, because we are always thinking about corporation, but we seldom think about how states could use this type of technology. And 1984 or Brave New World are not that far. If this type of technology is nationalized, I'm thinking about like certain countries that already have a score for how well you're behaving as a human being, right?
Right.
So
Yeah, I think it's going to be fascinating. I do feel like I think a lot of things are possible. Like I think like overall, like if you think about it, it's possible to create like a utopia, or it's possible to create a dystopia in a sense. The future will definitely be very different from the present, and I think a lot of it might just depend on like the people who are taking in charge of the technology and building it. Like, can the right set of people go and like build a safe future for the rest of humanity? I think that will become very important, and and being able to ensure that we do it in a very safe and like good way where we don't somehow like create a lot of like crisis, because like the a lot of things might change in the world, but you have to just like make sure you change it in the right way. I don't think there's like a risk of like existential crisis. I think that's not happening soon. The risk will just be like a lot of like things might just change really fast, like society might change really fast and how we do things might change really fast, and then like getting used to that, making sure like we don't unequally distribute like technology. Like suppose like if all the technology happens in US, what happens to third world countries? So they just like lose out the whole race. So like the distribution of resources and the wealth that will be created will be interesting. So I will definitely say it will be like it's a new era. We have seen some early precursors to it. I don't think we have seen the whole thing yet, where I think once it starts working, it will be like the new internet or the like the start of the computer revolution.
you talk about the iPhone moment during the interview. What do you think will be the iPhone moment of this new era?
I will say I can start using it to do useful things, because like a lot of what we have seen right now is chat or maybe like finding information, which is like yeah, I can maybe it saves me time, but it may be like saving you time, but it's not a very new thing. I think the new thing might just be like okay, like now maybe like I would say like talking to your computer will be like the new thing, where like I actually don't have to do anything.
Yeah, that would be interesting. I have one last question, which I'm carrying with me from the very beginning of the interview. And I put like a question, like maybe ask later. Because it fits in the interview, but it's kind of a side pocket. And it's the relationship between AI, robotics, and neuroscience. One field that feels like we're still very much behind is that of robotics. I would have thought, like in my imagination, that before I saw an AI that can create beautiful paintings like Dali with a simple prompt, I would have seen a robot cleaning my kitchen. Instead, turns out that that's not happening anytime soon. So maybe on a high level, but what are the challenges integrating robotics with AI? But if AI has arms and legs, what more can it learn? What if it can experience the physical space instead of just observing it.
Right. Yeah, I think so. Like, I think the hardware, the challenge is like hardware, it's always very hard to build. Like, you have to like do a lot of mechanical stuff, electrical stuff. So you have to figure all of that out before you can actually start putting like the software part into it. And I think that becomes a challenge because like it's very easy for hardware to fail. So building a very robust like hardware system itself is a really, really big challenge. And then also like how do I go and mass produce that hardware distribute that hardware, which because that basically involves like setting up factories and assembly lines and hiring like lots of people and figuring out how to like reduce the cost drastically and like doing that stuff. So I will say it becomes like really hard to do that. And I think that's one of the robots we don't see that many robots. Like maybe like the one robot you see in your daily life is just like a vacuum cleaner. It's sort of like a Roomba, and that's probably one of the easiest robot that you can build because it's basically like such a simple form factor, very easy to mass produce and have it do anything. So a lot of robots actually don't move from the prototype phase to the actual production phase just because people can't figure out how to like actually mass produce them, and I think that becomes like a very, very big challenge. But I do think like what is the right way to solve this is just like solve it in parallel. So I think intelligence will be solved in parallel, and like how do you develop better, cheaper, scalable hardware can be solved in parallel, and then at some point you can combine them together. And I do see that as the right pathway. Another thing that's really hard for robots is collecting data because it's so hard to collect data because you have to put so many robots out there or like get a lot of physical stuff. So I think that problem will also be solved over time, but I think it will just take much more time. So could be like 5 years before you see like prevalent robots in households. It's definitely going to happen, but it's also a much harder challenge just because of like so many things you have to first figure out. Whereas like if I was to just like focus on building like AI itself, then you can just go and like do that really fast compared to having to figure out how to build the other parts too.
Yeah, makes sense. Div, I want to thank you so much for the time that you have given me for answering so many questions. It was fantastic to have you as a guest. And for
Definitely.
listeners, we'll see you in the next episode. Bye. That's all from today's episode. Thank you so much for watching or listening. If you find this episode valuable, you can subscribe to our YouTube channel or to the Polyweb podcast on Spotify, Apple, or your favorite podcast app. It would be fantastic if you could leave us a rating, a review, or a comment, as this really helps other listeners find the show. All the resources mentioned in this episode will be linked in the description and in the show notes. See you on the next episode. And if you cannot wait until next week, you can watch this episode right here that relates to some of the things that we talk about in this episode. Bye.